Alright, this is lecture number 5. Today we'll review some of the information we talked about last week, and we'll also talk about the scientific method, which will be incredibly important for the rest of the semester as this class focuses on the social scientific research that looks at mass communication. There are other forms of research that looks at mass communication, such as narrative research, which would fall into the English department, but since we're a communication department and we focus on social scientific methods, we'll be talking about those and that type of research throughout the rest of the course. So our focus on content thus far has looked at media effects in 3 different levels, that is cognitive effects, attitudinal effects, and behavioral effects. However, I want to point out that media researchers are also concerned with media selection, that is what we choose to watch, normativity, that is, what are the functions of the media? Does the media lead to social betterment? Does it lead to society working better? Those are kind of normative questions. And also with audiences. So who are the audiences for specific types of media? How can we predict which audiences will like certain types of media? How can we predict which audiences will select certain types of media? So the audience is also an important concept here, especially when we're talking about effects. I just want to point out we'll talk about some of these other theories later this week. There will be a lecture on audiences. There will also be a lecture on media selection, one of the bigger theories that focuses on media selection, which is uses and gratifications theory. That theory also ties into normativity. So all 3 of these concepts will be hinted upon in future lectures this week. Last week I also talked about kind of monkey see, monkey do effects. These can also be called copycat effects. These types of effects tend to get lots of media attention. So when someone shoots up a school, as they did in Virginia Tech several years ago, or Columbine back in the 90s, people often talk about how the perpetrators were merely mimicking what they saw in the media. And I just wanted to talk about a few things here before we move on. That these big copycat crimes tend to be rare. We don't see a lot of people going out and mimicking Grand Theft Auto. Because they're so rare, there aren't really enough data points for any type of systematic study. So we don't have really good scientific research looking at copycat crimes. We do see mimicking behaviors with children are not as rare as other forms. So we see children mimic media behaviors a lot. But most of this research is focused only on violent media, and it hasn't looked at other forms of media. And lastly, there really isn't a theory yet to explain why most people can watch vast amounts of violent media and see no ill effects. So when you hear media personalities or anyone talking about how media leads to big violent crimes such as Columbine or the Virginia Tech massacre, there really isn't any good reason to, or any good evidence to support that. If you think about Grand Theft Auto 4, right, which people would say has led to many violent crimes, that's really not a true statement. If you think about how many people have played Grand Theft Auto 4, it's made over $1 billion in sales, and yet there are very, very few people that have actually gone out and replicated the crimes that they saw in Grand Theft Auto 4. So when you're talking about causation, there should be a larger correlation there than just 2 or 3 people going out and committing these crimes. Anyway, that's just my spiel right now on copycat effects. We'll be talking about those more when we get to social cognitive theory, which is a theory that specifically explains why we might see copycat effects. Still, I want to point out, this is a big area of concern because these crimes are so violent, but it's just not a lot of evidence that media are contributing to them. Alright, so before we talk about the scientific method, I want to talk a little bit about communication models. So communication models focus on how media messages or how any communicated message spreads out. We use these models to help understand media effects phenomena. So how is it that someone could watch a film and then feel sad or feel happy? What do those effects lead to? But we basically use these as a simplified abstract representation of a more complex reality. Now what that means is that reality is very complex and it's hard to see all of the components of a specific process. But what a model helps us do is it helps us break down those processes and kind of configure them in a way that might make sense theoretically, or maybe just based on a hunch that we have. So I'll go through and I'll talk about how we evaluate models, and then I'll give you some examples of models. Now, the criteria for evaluating models are heuristic value, scope, prediction, and then parsimony. I'll go through and talk a little bit about each one of these. Heuristic value basically means, does it help us break down a complex process into something that's more easily understood? A heuristic you can think of as being a mental shortcut. So one example of a heuristic is you get what you pay for, right? Now, if we look at that heuristic, it implies that the better something is, the more it's going to cost. And that tends to be true in the world when we look at things, right? If you want a really nice car, you're going to end up paying a lot more money than if you want just a beater to get you to and from work. So that's what a heuristic is. It's this simple kind of mental shortcut that helps us make sense of something more complex. So you get what you pay for is a type of heuristic. Well, models also have that same heuristic value. Does it provide us with a shortcut that helps us understand the process better? That's kind of what heuristic value is. Scope refers to how much information or how much material or how much of the process does it cover. Now, you can have models that have really broad scopes that cover lots of different components of a process, and you can have models that are relatively small and only cover one specific component. If you think of physics, right, you can have some of their models are good at explaining what happens on large scales, and some of their models are very good at explaining what happens on really kind of subatomic scales. And the same models don't work on both. They're looking for a broad-based model that would explain both subatomic relationships as well as regular relationships above the subatomic level, but they don't necessarily have one yet, and that's kind of what the scope is. So if we break this down into media, we might have a model that explains why people select something. So it might explain, that what they think and what they feel determines what they're going to select. Now, that model would be less broad than a model that explains what they select and also what the effect of their selection is. We'll go through and I'll point out some different models and talk about this later, but scope is basically how broad is the model. Prediction is basically how well does it predict the phenomenon in question. If a model explains the phenomenon completely and predicts all of the components, it's better than a model that doesn't predict this, the relationships very well. So prediction is basically how well can we predict what's actually going on in reality. If we have a model that says the more violent media you consume, the more aggressive you are, if we look at evidence for that, the evidence should show positive correlations, right? It should show that the more TV you watch or the more violent TV you watch, the more aggressive you are. That deals with prediction. It should also predict that if we expose people to violent media compared to non-violent media, they should act more aggressive after seeing the violent media than after the non-aggressive media. So if we see positive correlations there, then that model is predicting well. If we don't see positive correlations there, the model isn't doing so hot. So that's what prediction is. Does reality match up with the predictions of the model? Parsimony basically means, is it as simple as it can be? If we think about models, we don't want a lot of unnecessary steps in our models. We don't want it to include things that shouldn't be included, just as we don't want it to exclude things that should be included. So if it's including things that are meaningless, that's not a very parsimonious model. If it is not including things that it should be including, that's not a very parsimonious model either. This basically breaks down to Occam's razor. You should look that up, see what that means. But basically it just means that whatever you can cut away, you should, and whatever you can't cut away, you should keep. But everything should be as simple as possible. Now, I've posted a video on Angel that gives a nice demonstration of a model from ancient times that was very broad in scope. It had heuristic value. It predicted very well, but it wasn't very parsimonious. This is the Ptolemaic model of the universe, which basically guided all of our understandings about how the universe worked for several thousands of years and was eventually replaced by Copernicus's model, which instead placed the sun at the center of the universe rather than the Earth. So there's a nice little example there that shows that you can have a model that predicts really well, that is broad in scope, but it might not be the best model because it might not be as parsimonious as something else. So watch that video and let me know what you think. Communication models. Now we've talked about evaluating a model. I just want to point out there are lots and lots of models in the communication discipline alone. We have models that predict attitude change. We have numerous models that predict attitude change, in fact. We have models that predict media selection, so why do we pick what we pick to watch? We have models that predict effects, behavioral effects. We have models that predict cognitive effects. So we have lots and lots of models. And these different models can mean different things. So the definition we'll be talking about mostly is this pictorial or graphic means of explanation. So it explains a complex process using charts, using images. But that's not the only definition of a model. A model can also be a mathematical formula that represents assumptions about a phenomenon. So there are mathematical formulas that predict how ocean waves are formed. There are mathematical formulas that predict how clouds combine with each other, and we use those to predict weather, right? These mathematical formulas tend to be rarer in communication because our discipline is not as well defined as, or at least it hasn't had as many years to define itself as other disciplines such as physics and chemistry. But mathematical models are starting to be used a little bit more in communication and in social psych research in general. But basically they're, like it says, formulas that represent the phenomenon. So they use mathematical equations to predict outcomes from phenomenon, so probabilities, but also actual behavior and things like that. Like I said, they're not as common right now, but they're becoming more common. The word model can also refer to a broader paradigm, such as the limited effects or strong effects models that we talked about in the previous lecture on the history of communication. So those are different models that basically represent a broad paradigm. Now a paradigm is a little bit broader than a model, but they're kind of similar. A paradigm basically is like the overarching assumptions that guide a field. And if you remember back to our lecture, we had different assumptions at the beginning of the field during the magic bullet model years compared to the more recent model limited effects years. So that also can be the word model. So just remember that pictorial and graphic means of explanations are what we will use. So now I'm going to show you some classic models. This first one is the Shannon-Weaver model. This is the first model, basically, of communication. And if you notice, it's a one-directional model. So if we look at the left, we have our information source. It's sending out a message to a transmitter. The transmitter is converting it into a signal and sending that signal to a receiver. The receiver is then sending that message to the destination. You also notice there's noise in there. There's that noise source that affects the signal. So this is basically explaining how telegraphs are sent, right? You have an information source, that's the person working the Morse code device, right? He taps in the code, that's sending it into the transmitter, which converts it to electrical impulses, the signal. The signal then travels along lines of communication, so like telephone lines, and it's sent to a receiver. The receiver then sends the message to the destination, and the destination receives these impulses that they can then decode into text. So that's basically what the Shannon-Weaver model demonstrates. It demonstrates how information is transmitted through space from one information source to a destination. It's associated with early telecommunication and information probability theory, and this is kind of like the first model of communication. So remember, it's one-directional. It was kind of the first model to explicate the process. Now, one thing you might see that this is missing is that there isn't a feedback loop, right? So there isn't a way for information to get from the destination to the source. So while this is good at explaining telegraphs, right, which are based on one-directional information flow, it's not very good at talking about a telephone-type message. So this is the Schramm interactive model. This includes a feedback loop. If you notice the big circles on both sides of the screen, one says encoder, interpreter, decoder, the other says decoder, interpreter, encoder, you can think about those as being individuals. Now each individual can interpret, can encode, and can decode messages at the same time. So let's pretend these people are talking on a phone. If you look on the person on the left, they kind of send a message out, so they're talking. The person on the right can interpret that message, but they can also formulate their next or follow-up message while they're listening, and then they can send that message back. So this is more of a cyclical process. It allows for information to flow in two different directions and accounts for feedback in the process. Now, most mass media messages that we talked about, like we talked about last week, are unidirectional, right? They're sending information out and they're not really getting a lot of information back. However, we can also think about these mass media models as being within an individual, so how individuals deal with the messages once they receive them. Here is a unidirectional internal model, so it explains the microprocesses of what happens after an individual receives a message. So we have our inputs at the top, a person and a situation. We have routes of persuasion or internal state, so we have the affect, cognition, and arousal. We then have outcomes, and I'll try to go through this to lead you through the situation, right? So we have this social encounter over here on the right. Now let's pretend that's just someone stepping on someone's shoe at a movie theater. So Jim steps on John's shoe at a movie theater. Now John is the person, and he's also in a specific situation, right? So maybe the situation has led him to have a specific internal state, so moving down to that route, right? Maybe he's in a bad mood, so he's got low affect. He's not really thinking a lot, so he has low cognition. And also, maybe he's really highly aroused, so he's just watched a movie that makes him angry. Now, in that situation, he has appraisal and decision processes that come after he's had his shoe stepped on, right? That social encounter. Now, he could have a thoughtful action, which would probably tell him, you know what, who cares, it's just my shoe. I'll just say, oh, that's okay, don't worry about it. Or he could have an impulsive action where he shoves the person who stepped on his shoe. Now you can see this tries to break down a lot of complex processes into a general model. And this basically argues how individuals respond to social situations. Generally, people can have thoughtful actions or impulsive actions, and those actions can be either aggressive or non-aggressive. And those social encounters, in turn, shape those internal states, right? So they shape our cognitions, what we know about the world, our mental processes, those mental models that we've talked about before. They also shape our affect, and they also shape our arousal. And those three things, in turn, influence how we appraise the situation and the decisions we make afterwards. So you can see that this kind of tries to break down a complex process that you probably don't think about into something that you can wrap your head around. Models can also highlight different aspects of communication, which is important to remember. They can highlight interactions, they can highlight transactions, they can highlight short-term effects, long-term effects, individual effects, or aggregate effects. So a model might predict just on short-term effects, right? It might try to predict, if you see a commercial, how likely are you to go out and buy food that day? Or it might predict long-term effects, right? What is the effect of seeing tons of McDonald's ads over your life? How does that, in turn, shape your views of McDonald's? It could focus on individual effects, so how does a message influence one specific individual? Or it can focus on aggregate effects. How does a message influence society at large? So these are all different aspects of communication that can be highlighted by models. Alright, so now that we've talked about models, which are kind of the basis of scientific theory, I'm going to talk a little bit about the scientific method. Here are some words that you should know, some keywords, and I'll go through and talk about each one of these individually. Theory and hypothesis, inductive versus deductive logic, concepts, constructs, qualitative versus quantitative research, triangulation, and then what a variable is. So when we think about what theory is basically a systematic explanation of a process. Basically, it gives us some generalizations that help explain some observable phenomena by linking constructs and variables in terms of organizing principles that are internally consistent. So there's a lot of things there, but basically a theory proposes certain general phenomena. The theory of gravity, for example, proposes that there is a force acting on objects on Earth that causes them to move towards the Earth. So that's the observable phenomena we know, right? We know that apples fall from trees. We know that things fall towards the Earth. Now, why is that? Well, you could say, well, they like to be near the ground. That's one set of generalization that you can make, right? That all objects like to be close to the Earth because they're scared of falling off of it, right? That's a generalization. It doesn't really make a lot of sense, but that's one type of generalization. Now, there's another generalization you can make, and you can say, well, the Earth has mass, and mass attracts other mass. Now, that's actually the real generalization and what's really going on, but that's a theory, right? It's something that you have to test. It's been tested very well. That turns out to be pretty much true. But you have an observable phenomena, and you're making a generalization about it. Now we're linking constructs and variables and organizing principles, right? So we're linking like constructs, for example, the force of mass, right? We're linking variables, the mass of the object being drawn towards Earth. That can vary. And we're linking them together, and we're trying to make it internally consistent. Now, internally consistent basically means that you don't have counterintuitive predictions, right? If you had a model of gravity that said sometimes objects will fall towards the Earth and sometimes they're going to fly away from the Earth and we don't know why, that's not very internally consistent, right? Because it's predicting the same outcome for two different processes. It doesn't make a lot of sense. So we evaluate these theories with the same criteria that we evaluate models. So go back and check those out, but they basically fit the entire, fit completely with theories as well, right? We don't want theories that have a lot of useless information in them. We want theories to be heuristic. We want them to predict phenomena well. Now, you take a theory, theories generally are made up of different hypotheses, right? So a hypothesis is a specific prediction. It's predicting a specific relationship that you should see. So going back to the theory of gravity, right, if we predict that mass attracts mass, then that's a specific prediction that we can try to observe, right? We can observe, well, is that true? Well, we can see things like the moon causing tidal waves, right, or causing the tides. That's a specific prediction that's meted out by that, right, that mass attracts mass. So we should see that the moon affects the matter of the ocean on the Earth. And guess what? We do see that. So we're seeing kind of support for this hypothesis or this very specific prediction. Another specific prediction, right, could be that viewing media a lot causes you to have bad personal relationships. So we can test that out, right? We can test that if people watch tons of media, do they have less satisfaction in their relationship? That's a specific prediction we can test. All right, I hope this is making sense. All right, inductive versus deductive logic. Inductive logic says basically generalizing from something specific to something more general. So induction is basically, well, this works in this way. If I apply it to another area, does it work the same? If you think back to Sherlock Holmes when he says deduction, Watson, he's really lying. It's not really deduction, it's induction that he's making. He's trying to predict something based on data that he's observed in another situation. So he's trying to generalize from a specific situation to something more general. You can see a failure of inductive logic with the mass media violence example I gave earlier, right? So we see that, you know what, lots of copies of Grand Theft Auto are being sold and not that many people are killing people. In fact, violence in the country has gone down every year since the 80s. So people who argue that video games causes violence have to try to explain why that specific situation, right, isn't applying to something more general. Deductive logic is making a specific prediction from general principles. So this is basically just applying the general principles to the same situation. It's basically the conclusion necessarily follows from the premises. I'll try to post a video that outlines inductive versus deductive reasoning so you can see the clear difference there. Other important concepts for scientific theory are the idea of a concept in general, right? It's a general idea derived from many specific particulars. So we have these particular instances and we can try to craft some kind of general idea from them. So one example is social class, right? It's something that we're familiar with, but it's generalized from particulars like income, education, status, occupation, and esteem, right? So you can have a job that pays a lot of money, you can have high education, you can have high status, You can have a good occupation, and you can have an occupation that's valued by society, and that would put you in a high social class. Similarly, you can have very low income, you can have low education, you can have low status, you can have a low occupation, and you can have low esteem of your occupation, so nobody finds it particularly valuable, and you would be kind of considered low social class. You can have mixtures of these, right? But basically the idea is that social class, this idea that we have about individuals, is basically made up of all these little components. And that's kind of what a concept is. It's something that's a larger description of specific instances of various components. Now, a concept can be measured, like we were just talking about with social class, right? So we can measure many of those things. We can measure your income. We can measure your grade level. We can measure a lot of those aspects directly, right? I can just ask you, how much money do you make a year? You can tell me. How much education do you have? You can tell me. And that can basically be measured that way. That's what a concept is, right? It can be kind of measured. But it can also describe something psychological that can't be directly measured, right? So if we think about personality, I can't look at you and measure your personality the same way as I can measure your height. But I can measure your personality by using what we call indicators. Now, indicators basically can vary. You can respond to them, and we can think of certain things that indicate certain types of personality, right? So if I ask you a question, such as, would you rather stay home at night and read a book, or would you rather go out with friends to a bar? The way you answer that question can tell me a little bit about your personality, right? If you say you'd rather stay at home at night and read a book, I can think, well, maybe this person's more introspective than if you answer the question, you know, I would like to go out to a bar with my friends. That might mean you're more of an extrovert, right? So we can start to figure out things like personality that you can't directly measure by using these indicators. In addition, we can have index variables versus latent variables. An index variable basically means that you add up all the responses to your questions, and that kind of gives you an index. So it varies from 1 to 100, and right. So if you answer however many questions you answer yes to, that basically you can add those up, and that tells you something about the person. You can also have a latent variable, which that basically means you have this outside construct, and that's influencing how you respond to the questions. To be honest, this isn't going to be an incredibly important part of the class, but it's just basically two ways we can think about constructs. I'll try to point out index versus latent variables later in the course when we start to talk about specific hypotheses and specific theories. You also have quantitative versus qualitative research. Quantitative research is a research method of describing, qualitative research is a research method of describing phenomena without relying much on numbers. It allows for holistic analysis using words only. Whereas quantitative research is research methods that use something to describe relative amounts of the phenomena in question. So with qualitative research, you're not really testing your theories using data, using numbers, using correlations. You're just kind of analyzing something in general. So critical theory, so like film critics, right? That's kind of qualitative research. They describe the phenomena, but they're not really relying on numbers to try to explain phenomena, right? They're just kind of looking at it broader in a more holistic fashion. Now, quantitative research, which is the research we'll be talking about more in class, is research that uses numbers. So we're looking at correlations. We're looking at differences between averages for different groups, right? So we might look at how many hours a day do people watch television, right? That's a quantitative type question because we can quantify it, right? We can apply a number to it. We can measure how much each individual watches television. Then we can average those together to come up with the average amount that people watch television. Whereas a qualitative researcher wouldn't ask that type of question, right? He wouldn't ask, how much do people watch television? He might ask, how do people watch television? And then he might just go to people's houses and say, hey, can I watch you guys watch television, and make some notes? And so he might write down, a description of how, a family meets in the living room to watch television, and who gets to control the remote, and why is that important? It's not really dealing with numbers. Hope that makes sense. All right. In addition, variables are what we're interested in measuring. variables can be anything to which more than one value can be assigned. So, for example, hair color is a variable. There are many different values of hair color, right? Blonde is a value of hair color, brown is a value of hair color, red, etc. So you can have different values there. Gender is a variable, right? There are basically two genders, right? Male, female. In fact, people sometimes talk about gender being a continuous variable, with male being on one end of the spectrum and female being on the other end of the spectrum, and people falling somewhere in between the two generally. Time spent consuming media is a variable, right? You can spend hours and hours, you can spend a few minutes. Personality traits are a variable. Intelligence is a variable. All these things are variables because the value can change for them. Things that aren't variables are things that can't change, right? There aren't more than one value for them. But what we're going to be generally interested in are not constants, which are those things that don't have more than one value. We're going to be interested in variables, things that do have different values. Now, just continuing on, triangulation is something else that's going to be very important. This is used basically in an informal sense to mean the set of different methods to get at the same research question. So, for example, media violence. Let's say we believe that media causes people to be violent or causes people to be aggressive. Well, we could just ask people, do you feel more aggressive now? And we could base our response on that. But we might want to do it in several different ways, right? We might want to measure their behavior after they watch media. So we might go to a school and show some children a violent cartoon and show other children a non-violent cartoon, and then go watch them at recess and see whether or not the children who are exposed to the violent cartoon act more aggressive, which would be behavioral data, than the children who are exposed to the non-violent cartoon. We might ask the children how they feel afterwards. How angry do you feel? How happy do you feel? That would be a self-report type measure. And then we also might measure physiological data, right? We might measure the amount of testosterone that is built up in adults after they watch a violent movie or a horror movie. Do they have increased peaks of testosterone in their blood? That's a physiological measure. So you can take all three of these, and if all three are pointing to the same thing, that's kind of what triangulation is, right? So what if we saw that the self-report data indicated that people were more aggressive, but we don't see any behavioral evidence, so they're not acting more aggressively, and we don't see any physiological evidence. Their body chemistry hasn't changed, and we don't see these markers of aggressive behavior. Well, then we might know that might tell us that, well, maybe media violence just causes people to think they're going to be more aggressive, and then they actually aren't. However, if we saw positive evidence for all three of these, right, they were acting more aggressively, they were reporting to us that they felt more aggressive, and then physiologically we saw increases in testosterone or some other aggressive marker or aggressive hormone, then we might be able to predict it, or we might be able to say with more confidence. So this is all about adding confidence to our questions, and basically you want to have this kind of triangulation in the research. This is what we strive for. Now, you can't do it all in one study, but lots of different studies employ different methodologies, right? Some studies measure behavior, some studies just measure self-report, and other studies measure physiological data. So the more measures you have, the more you can be sure of a specific phenomenon. All right, two more slides. This slide outlines basically the methods that are used for research. So there's laboratory experiments, there's field experiments, there's survey research, there's longitudinal studies, there are focus groups, there are meta-analysis, and then there's content analysis. Now I'll go through each one of these in an additional lecture, which will be coming up next, and talk about what basically describes this method and what the method is good for. So not all methods are equally good, right? Some methods are going to tell us a lot about what's in the media, what representations are there, but they're not going to tell us about the effects of media. So I'll talk about which one is good for what in the next lecture, and that'll be important for the rest of the course as well. Now, the last thing I want to talk about was, I talked a little bit about quantitative research earlier. I just want to point out that we really rely heavily on statistics in this discipline. We use statistics to test hypotheses. We use statistics to determine whether our theories are correct. And this is common in most scientific disciplines, and especially in social scientific disciplines. So just as an example, the Higgs boson particle, which has been in the news for the last week or so, which they just discovered, that discovery isn't based on absolute knowledge. It's based on a statistical test that they did. So they basically said, well, what is the probability that we would see this type of data given that the Higgs boson particle doesn't exist? And basically the chances of them seeing that were really, really small, like less than 1 in a million. So the chances that the data that would come out that way are based on statistics. Statistics are used in climate science, right, to predict why is it that people are so sure that the world is getting warmer and global warming is real. Well, because we're seeing more record highs than we've ever seen. The record high keeps increasing every year, and this has happened for the last 50 years. And they can link it to things like carbon dioxide production, and they can link it to all sorts of other markers in the environment. Why is it that evolution is real? Well, because based on statistical tests, we know that the chances that we would have the similar DNA and et cetera, are really, really small. So all of these things are based on statistics, and this is true in both science and in social science. All right, so that's the end of the lecture. Go ahead and check out the next lecture to learn about the different social scientific methods, or the methods that we use in communication.